Hi, and welcome back to another VC Libraries Open Code Review. I'm Stefan T. Lauid, a Visual C++ Libraries developer, and today we'll be looking at PR3035, adding stdviewszip from a new contributor, Tyler Brawl. So this is a 1,000-line PR, 1,311 lines, but it's entirely adding new code, not changing existing code. I'll be doing the final review of it. Nicole has already reviewed this for correctness. Now, I have not looked deeply into stdzip. The committee has been adding all this ranges stuff to CS+23. So I'm vaguely aware of what it does, but I'll be looking at the standardies for the first time. So this describes this nice detailed description that Tyler's provided. Explains that this is a partial feature implementation, so it's not completely implementing the paper, but only stdviewszip. The paper also adds a stdviewszip transform, which we won't be seeing today, but it may come in a future follow-up PR. So let me open up the tracking issue. Because this is a partial PR, this means that we will not be getting the feature test macro, because our policy is that we only define a feature test macro when a feature is complete and non-buggy enough to actually be usable. If something is blocked by like severe compiler bugs, for example, we will refrain from defining the feature test macro until it is usable. So we won't be having this bit. There are a couple of LWG issues that affect this. One is implemented, one is not, because it affects zip transform. And there's a couple overlapping patch papers that do modify stdzip. So we're going to need to open up all this stuff. This is the primary paper. And then the library issues we need to look at are this one and this one. OK. And this has all been added to the latest working paper and 4917. So I'll actually probably be referring to that because the code has been patched extensively, or the specification has been patched extensively. OK, so this should be easier because it's mostly adding new wording, so we don't need to jump around a bunch of different places. And I think, was zip the one that we've already gotten? This seems really familiar. The tuple and pair and vectorable reference changes from? Or was that another paper? I think we already got those. Okay,
we do
good.
already have the tuple and pair changes from this. I think Zhang submitted that change.
That's right. Yeah. So we merged that a while ago. Trying to load all this state back to my head. The change log explains all this. I think if we search for zip, yeah, here we go. It's shipped. It's in the current production release, VS 2022-17.3. So essentially, the first part of the paper is implemented, the tuple pair and vectorable reference that affects the existing library. So this will be the second of at least 3 parts. So here's the zip paper. So tuple, pair, all this stuff is done. Go down. OK. So I think this is explanations to integer class type. Common type stuff. OK, so the new zip stuff is in range.zip. That's a stable name. We're not going to be looking at zip transform. And then there's also an adjacent and adjacent transform. Do we have this? I think no, according to this description. Did this mention adjacent? No, no adjacent.
No, we don't.
OK, so this is purely
we
zip.
Just have zip. Yeah, we don't have
so
zip transform or adjacent transform.
OK, so we may be seeing several follow-up PRs. This is good. It means it's more bite size. We only have to look at one section worth of wording. OK, I'm just checking here to see if there's other edits that range-zip did outside. I'm almost certain that it's not. Lots of effects equivalent to stuff, a sentinel. OK, so now I'm going to close this paper, and I'm just going to look at what's in the standard. Let me look at LWG issue. This is also updating a spaceship standardies, again, in range-zip iterator. OK, so this has already been applied to the working paper. Yep. And this is the compatibility paper. Scroll down. What wording did this affect? OK, so tuple, this has already been taken care of. Tuple-like. Yep. Function with tuple, equality for tuple. Common reference specialization. I can't remember if we got this. Hair stuff. Let me scroll faster. This also edits zip transform. No, at least not up there. Associative containers. Okay, did get rid of a pair-like concept. Okay, modified elements view. Okay, so it did change zip view. Okay, so looking at the current working paper will give us all that. Okay, great. So now let's look for ranges zip. Did I search for the wrong stable name? Probably. Ranges library. Okay, here we go. Zip view. Range.zip. Silly me. Okay. And okay, we got everything here. Okay, so let's actually look at the code and see if I can do side by side. There we go. Okay, so I want to minimize this real quick to see what we're looking at. Okay, most of the changes are to ranges, about 500 lines. Changes to our central internal header route valves core, and then adding a new test. Okay, I like to start easy. We're adding one new test directory, correctly spelled. The paper number, I'm just going to check the title here because I think that's right. 2321R2, 2321R2. This is the same paper number, but this one is view zip correctly sorted. Yep, that looks good. So the test will be run in the internal harness. We got a configuration here. Okay, so this one's a little custom, interesting. We've got our banner, which is good. Okay, so we've got a note here. Note, zip view underscore capital iterator defines ADL overloads for iter swap and iter move, so the test fails to compile unless permissive minus is set. So it needs strict mode. This issue isn't unique to zip view. All view types whose iterators define overloads for these functions have this requirement. Okay, so this is justifying why we've got the strict matrix, strict meaning permissive minus. This is something that ideally we could just enforce strictness all the time, but because some legacy programs don't exactly follow the standard, we are supporting the permissive mode, including in CS+20 and CS+23 mode, even though it would be nice if we didn't have to. And that's why most of our tests try to compile with the usual latest matrix, which means compile in 23 mode and throw in a permissive configuration. But if something absolutely cannot tolerate permissive, then we set the strict option and we have a matrix of options for that. So that's what this is. So we're going to use the strict, and ranges requires concepts. Latest means it's a 23 feature matrix. That's all correct. And then we're crossing it. So we're going to actually run this test 4 different times with test input, bidirectional, forward, and random. It's very interesting. Okay, I'm going to see why we need this. I'll remember that, but this is good. Okay, I'm going to briefly look at the test. Okay, good. We got our banner. Okay, we'll see what this test does. I'll come back. This is definitely unnecessary here. Also because we're silencing that clang warning now. Okay, so let's work our way towards the product code, central internal header. So here's a citation for the 2165R4. Now this one, this was just a patch paper. Did we have a top level? Did we have a tracking issue for this? Let's see. Half the work here is just information management. Okay, so we actually do have a tracking issue for this. So we do consider a top level feature, and I guess we're implementing incrementally. Okay, so this is the correct cleaned up name and spelling. Yep. Is it correctly sorted? 213, 2165, 2166. Yes, it is. Compatibility between two parent tuple-like objects. And then we have a explanation changes to view zip only. Okay, good. And then the zip paper. Previously, we said it's pair tuple and vector bool. And now we're going to flip it and say what we're missing. Missing views, zip transform, views adjacent, and views adjacent transform. Yep, 3 views. That's right. We got that Oxford comment there. Perfect. We're not defining a feature test macro yet, so no change to the feature test macro test. Okay, perfect. So let's look at the product code. Okay, ranges is including algorithm. Does algorithm include ranges? Let's check. Algorithm. Algorithm includes X memory. Okay. Don't think that means it includes ranges. But let's check real quick. Inc. Okay, ranges is mostly a leaf header in the STL. The stack adapter and the queue adapter, which are definitely leaves for the purposes of algorithm, drag it in and our internal stuff. Nothing else includes ranges itself. So there's no circularity issue here. It is not great from a throughput perspective that we got to drag an algorithm. Now, in some sense, it matters less because ranges is already quite big. And the CS+23 modules, which we just implemented, make this issue moot because it's so fast. But in the classic header world, there is a throughput impact to dragging in all the algorithm. Algorithm is 200 something kilobytes. It's quite large. I'm assuming, okay, actually, I'm not sure why we need this. What are we calling here? Be stood something something. Stood invoke is from type traits. That can't be it. Same with stood apply. What does zip need? We got decoval. Yeah, that's all. We got get. I don't see any use of algorithm, assuming that it would be a call to a non-ugly function. Just apply. That's all tuple stuff. I don't think this is necessary. Or if it is, I'm missing something. We have test coverage. We have a test called include each header alone that we've had running for over a decade that makes sure we can include each header from the STL in isolation, so we can't accidentally use stuff, at least in a way that explodes if you never call anything. So I'm not too worried about snipping out an include that we actually are using. But it sure doesn't look from this brief scan like we're using it. I'm going to recommend that I'm going to ask why we're using it. Let's see. Did Nicole ask?
Maybe they thought they needed it for iter swap.
Oh yeah, this did come up. Yeah, it was ranges max. That's interesting. Do we need the ranges version of max? Yeah, our contributor here mentioned that. Yeah, I think this is still an issue. I don't like the include algorithm, just because it's so big. Okay, so where's the use of max? No, oh, it would be parenthesized because of horribleness. We're maxing on an initializer list. And I'm assuming min is the okay, 2 uses of min. This one is forming an initializer list. Yeah, those are pretty small algorithms, I mean, relatively speaking. Do we only define them in algorithm and not like excitility? This is gonna be horrible.
It's probably the case that ranges max is only defined in the algorithm because we haven't needed it anywhere else before.
Right, the range is one, but I'm wondering if we could use classic. That element one is not.
I certainly think so. It looks like these are just difference types. So they're integer class types. Or sorry, integer-like types. They're integer-like types, so they should work okay with std min max.
Let's see, we've got, okay, these are the 2 arg forms.
We're not using a projection, okay. Right?
It's implemented in algorithm. So even if we call classic, we haven't needed them before. But could we promote them is the question. Yeah, you're right. There's no need for a projection or any of that fancy, powerful stuff. Where is max? It's in parens because macros. Okay, so this calls max element. This is the classic one. It just happens to occur after the ranges stuff. Okay, so we call max element unchecked. Where's that live? That lives in algorithm. Okay, it's non-trivial size because it also uses our vectorized thing, Alex Gutenyev's min-max optimization stuff. So it is larger than it used to be. I was mentally thinking, oh yeah, that's a tiny algorithm, but it's actually gotten a lot fancier and a lot more powerful. But otherwise, it doesn't really have a lot of dependencies. Interestingly, we would like to use the vectorized one here. Is utility core header? It's not, is it? Oh, it is. Oh, and we had that issue. All these complexities popping up. We've got this issue where core headers, which we try not to have runtime dependencies, if we try to promote a vectorized algorithm to them, that doesn't work. We encountered this in another context. I don't think it was min-max. It was something else we were trying to drag up here. And we ended up having to back that out. I think it was stood equal or something like that. So attempting to promote the min-max, even if it's just the classic initializer list one up here, that would be a problem. Okay, so it's not a trivial thing. Dragging in algorithm is not awesome for throughput, but maybe people should just be using import std. This is something we could potentially investigate in the future. The alternative is code duplication. Extract just a very simple hello world, just the core, not the stuff using the std max or the vectorized version. That way we wouldn't need to drag any algorithm. And we could do that if we really needed throughput. Ranges is, I think Casey is more familiar with the throughput of ranges. Ranges throughput is already pretty low. And I think it's possibly the header you would notice algorithm the least in, just because the denominator is already large. If algorithm was,
the
or sorry, if
initializer list
ranges was,
overloads of min-max and exutility instead of utility.
oh, exutility is non-core, right? No, exutility is oh yeah, that's the one that's non-core.
Exutility is not core.
Yeah, this one can use vector arguments just fine. This is where we put count, find. This one is reasonable to promote. Yeah,
this is the one step up from algorithm spot, right?
Yeah, that's a good point. That's why this exists. You could do that. And then does ranges already include exutility?
Yes.
Very, very likely. Oh yeah, because it includes like string view and tuple.
Indirectly from somewhere, but yeah, certainly it includes exutility.
Yeah, that's interesting. Most I'm just thinking of the logistics because we've got the toolset update I'm working on today that makes large scale code movement very obnoxious because it's reformatting a bunch of code. Aside from that, I see no reason why we couldn't promote this to exutility, and then ranges wouldn't need it. Let's see, should I comment that and then say hold off on actually doing anything there until at least the toolset update's in, and then we can move around code? Because I would hate for comment to cause horrible merge conflicts and wasted work. The alternative is do this thing and then file a follow-up issue to go improve the throughput later.
As much as Clang format has changed everything in ranges, I think this PR is going to have terrible merge conflicts anyway.
Yeah, but making it worse is strictly
merge conflict may not be that big of a deal.
Yeah. I'll include a comment. Or should I just resurrect this comment? Yeah, it is the same issue, so I think we can resurrect it. Okay, unresolve. Okay. Let's see, Casey and I talked about this in the video code review. We believe that exutility would be an appropriate place to move the initializer, say promote the classic initializer list. Actually, are they both using initializer lists, or was one using a non-init list but just arbitrary range? Sizes. Oh, sizes is literally an initializer list, and the other one we form braces. So init list would be sufficient. There's no need for the ranges.
I thought it was
Classic
just the
initializer
overloads.
list overload. Yeah. No need for the ranges machinery as it is included, or as it is let's see, well, I want to say higher up. That could be confusing. It's included by algorithm.
What
Algorithm.
excitility? Yes, it's included by algorithm.
And is non-core. We use it to centralize. Yeah, I won't explain. Yeah, maybe I will explain. And already centralizes similar algorithms of wide applicability in the STL. Yes, it is non-core. I mean, too much parenthetical. So the vectorization won't be problematic. Let's see. Note, due to the pending toolset update, I want to say it's 3155. Let's check. Whoop. Yes, I remember correctly. 3155, number 3155. Yep. Code movement may cause obnoxious formatting merge conflicts. I recommend waiting until the toolset update is merged before attempting to address this concern. Okay. I should probably mention that the throughput impact is, we should say we agree about the throughput impact. We share K's concern about the throughput impact of algorithm. Okay. Casey and I talked about this in the video code review. We share Hewell K's concern about the throughput impact of algorithm, and we believe the excitility would be an appropriate place to promote the classic initializer list overloads. No need for the ranges machinery, as it is included by algorithm and is non-core, so the vectorization won't be problematic, and already centralizes similar algorithms of wide applicability in the STL. Note, due to the pending toolset update 3155, code movement may cause obnoxious formatting merge conflicts. I recommend waiting until the toolset update is merged before attempting to address this concern. Okay, we've got one line of product code reviewed. Onward. Okay, so we've got some concepts here. Okay, this is actually kind of annoying. Let's split that. Okay. And minify this. Okay, that's readable. Okay, so we are translating over here. Oh, I was going to actually read the standards to see what's going on. We take a bunch of views and we get a view of tuples to references. So like if you've got a vector of ints and a vector of strings, and the ints go 10, 20, 30, and the strings say cute, fluffy kittens, then you can get a zip view that will give you tuples of references to 10 cute, 20 fluffy, 30 kittens. And then you can go feed those to some algorithm or something. And then viewzip as a customization point object that does that. Okay, one other thing that I want to be on the lookout for is usage of export. Because we have merged standard library modules, we need to make sure that every public name is marked with our internal export std macro. Because forgetting that will not immediately cause any problems, but is a bug. Eventually, this will become second nature to us, but for now, we need to make sure that we check this. Okay, so exposition only concept does not get exported. Let's switch to highlight here. Okay. So we've got template class .rs. These are underscore capital range types. We've got a concept called zip is common, which is exposition only. And it's going to be true when the size of dot, the range types is 1. and common range of the R's and dot, dot, dot. So they're all common ranges. And then using / / to hard wrap because of Clang format, which may not be necessary, but it's okay for now, with Clang format 15, which is better about this. Or, okay, and that's good that the or operator is coming at the beginning of the line because that's our convention. Okay, checking to make sure that everything is parenthesized correctly. Not that they're not all bidirectional ranges. So the not is outside the fold expression, good. And they're all common ranges. Or they're all random access ranges. And they're all sized ranges. Okay. Nice. Looks good. Okay, then we have a tuple transform closure. This is not depicted in the standard ease, up here at least. Is there anything else I can look for? Tuple transform. Okay, perhaps that's elsewhere. Search. What is this tuple transform thing that is being mentioned? Lots of equivalent twos. Did it already wrap? Come on. Here we go. Range adapter helpers. Okay. Exposition only. Let's see. This is making a tuple. Oh, I see. Tuple transform is apply. The tuple transform closure is just the lambda. Okay. Okay, so that's what this is. Okay, so we've got what the callback type, I guess that's F. Okay, this just calls it F. Here I'm thinking, should this be named callable type or anything? I'm okay with callback type. We do pass it to invoke, so really it is a callable type. The issue here is that in the STL, especially when overhauling invoke and std function, all that, we try to be very careful about terminology. If something's passed to invoke and it goes through the invoke protocol, the standard formally refers to that thing as a callable type, meaning that it could be a pointer to member function or pointer to member data in addition to something like a lambda function or a function object. And it is callable through some generalized syntax. So we try to be very careful about saying that. If this is like function type, I would definitely ask for change. I'm okay with callback type here. It's not user visible. Okay, so template on class callback type. This has to be const expr. This should really be no discard. It's internal. It's not absolutely necessary. I feel like it should be no discard, at least this one. There's very low risk of us calling this thing and dropping it on the floor. I don't know if this merits a comment. First, I'm wondering if tuple transform and the others here need to be marked. Usually with internal helpers, we do want to mark them. Because why would you call this if you don't return it? Yeah, we always return this stuff. I'd say it's fairly low risk. I won't ask for no discard here. I will think about it for the public functions. Okay. So going back here, tuple transform closure is just making the lambda, probably because defining this lambda is pretty obnoxious, so we want to centralize it. Okay, so template, custom experato, tuple transform closure. We take a callback by L value reference. Okay. We are no except because we only store a reference to the callback. So we're not actually copying anything, so we can guarantee that we aren't throwing exceptions. Okay, so we're going to return. We, instead of just using a capture default, we name ref callback, and this is a generic lambda. So we're templated on class dot 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 view tuple types in place of t's. We take t's ref dot 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 view tuples. Okay, so that's this so far here. And then we return, we make a tuple of the invoke result T. Here we've got to check that the types are exactly being mentioned because the value category and CV qualifiers can influence the result. The callback type ref and view tuple types ... Yep, that's good. And then we're calling it with, or constructing this from the result of std invoke, the callback, and then std forward, view tuple types, view tuples dot. Okay, that's all good. Okay, so that's essentially this here, but not the apply, that's elsewhere. And then this is the apply call. Template on class underscore capital callback type, class under tuple type, context for auto tuple transform. Okay, this takes by perfect forwarding a callback type ref callback. And so that's matching this context for auto tuple transform. That's depicted as fref, and then tuple type ref under tuple. Here we're strengthening. This is being commented as strengthened, even though it's not actually a standard function. But because it's depicted in the standard as exposition only, I think it's reasonable to have a strengthened comment here. We're no except if this is no except. Std apply, so this is just going to be the body. Std apply, yeah, that all matches. So we're going to return std apply to avoid ADL of make that closure, and then std forward tuple type tuple. Okay, correct. Okay, so that's this thing done. And then we've got a tuple for each. Same structure where we've got one helper to make the lambda and then another to actually apply it. So template callback type, context for auto, tuple for each closure, and take by L value ref callback. This one's always no except because we only capture a ref. Return, okay, so now this is the stuff. Capture ref to callback, class dot view tuple types, take that ref view tuples. The lambda itself could grow, so it definitely should not be no except or anything. Here we are casting the result to void because we don't want to invoke any sort of overloaded comma, which is good. So we call std invoke of the callback, and then std forward view tuple types, view tuples. And then what is going on here? This parenthesis is not actually necessary because what else could the void bind to? It's not wrong. It might help visually parsing it. I don't think I'll complain. I'm trying to be a little bit less nitpicky in my comments, and here the extra paren is not the worst. This is already pretty complicated expression, so I won't grind my teeth if there's an extra paren here. It's unusual enough that I'm okay with it. Then comma ... Okay, so that's good. Very like the attention to detail that the standard doesn't bother to avoid overloaded comma here, but we need to according to our policies. And a strict reading of the standard does indicate that that's correct. Std forward. Okay, very semi-good. And then tuple for each is the whole thing. Template, callback type, tuple type, context for void, tuple for each. Here I'm checking that all the names are ugly, and they are. Callback type ref callback, tuple type ref tuple. We're no except if this is no except. Std apply for each closure, tuple type. Again, it's marked as strengthen. That's fine. And then we just drop the return value on the floor. No need to cast because std apply is not no discard. Okay, that's good. So we've got the tuple for each. Close enough. Now we've got helpers. Okay, let's go back to zip view. Range.zip as we discovered. I want the whole stable name. This will cooperate. Come on. There we go. Okay, this is not depicting an all random access, but I'm guessing it's going to come up here. Yeah, with that maybe const stuff. Okay. So what are we doing here? Again, internal machinery. Template on bool is const class.views. Concept, all random access is old expression. How do we ever live without them? Random access range, maybe const. So we apply the maybe const is const of views. Okay. All bidirectional is bidirectional range, blah. All forward is forward range, blah. Okay, that seems reasonable. Next up. Okay, another helper, zip get smallest distance. Is this depicted in the standard? Oh, and looky here, this is from iterator. Okay, so we can highlight this because it's done. All random access. Yep, that's that maybe const. Maybe const, maybe const. Yep, exactly fine. The standard names. Let's see. Does it have a zip get smallest distance? Likely this here. And there is some maximum stuff here. Okay, where exactly is this called? It's called in the minus of iterators, which is, in fact, what I'm looking at here, this is iter minus iter. Where's the general iter minus iter? No, I'm looking at Sentinel here. Iter minus iter, here we go. It's this stuff. Okay. So let's go back up to this definition. Okay, so what's happening here? Template, class underscore result type, class dot LHS tuple types, class dot RHS tuple types. Okay. And this is constrained to exist only when the size of the tuple types are the same. I'm not sure that this constraint is necessary. This is only needed, in general, you only need constraints to disambiguate overload resolution. If we can structurally guarantee that this is only called with identically sized tuples, then really this could be a static assert instead of a requires. In the olden days with when our only machinery was like Sphene with enable if, I would absolutely ask, yeah, this should be a static assert. Concepts are not as egregious as enable if, and it's still not conventional to use this when a static assert would suffice, but it's not completely wacky. I would be okay with this. I wouldn't have written it like this myself, but I don't view this as inherently objectionable. And perhaps someday it may even become good style. Just say, hey, you know, list your requirements up front rather than just assuming stuff and static asserting if it goes wrong. I could see an argument for that. I kind of think the static assert is cheaper in terms of throughput, but if it's not overloaded, I think it's about the same throughput anyways. Okay, I'll leave this for now. I'm not gonna comment on that. Mostly because it doesn't really have user impact. Okay, so this helper is marked no discard. That's interesting that the previous helpers were not. Slightly inconsistent, but at least this whole group wasn't marked and this is marked. Okay, I'll get this. So it's no discard, const expr. Okay, so we explicitly specify the result type, probably because we have to determine or use difference type or whatever. Zip get smallest distance. We take a const tuple of stuff ref, LHS tuple, const tuple of right stuff ref, RHS tuple. This is not strengthened in any way, but neither is the operator minus required to be. Is anybody calling this strengthened? Because we need to make sure at all levels. Look at this. So operator minus is strengthened to be, I'm no accept if this is no accept. What happens if we call zip get smallest distance? But then zip get smallest distance is never marked. So this is identical to no accept false. So this is an issue. If we're going to strengthen here, we got to strengthen this. Okay, so now it's time for a comment. Oh, wait, no, sorry. Wow, I can't parse this. It's hiding down here in this. I missed it because this claim format off looked like it was a body, but it's actually strengthened here. Okay, so it is strengthened, so we're fine. Okay, false alarm. Okay, so we take two tuples, suppress claim format, probably because it was dealing with this horribly. Interesting. We're no accept if fold expression, which is why we've got that extra layer parens here. Okay, so all of these things have got to be no accept. Static cast to result type of a std decal val const LHS tuple types ref. minus to decaval const RHS tuple types are F. So it's asking if we pairwise subtract each of these, left minus right, over and over, are all those expressions no except? Okay, that is correct, assuming that's what we're going to do here. Okay, I see Casey. Would you like to contribute something to the class?
I would like to suggest that we use the names of the parameters instead of calling std-decal-val to get things of this type and value category.
But then we would need get and we would need index because these are the elements of the tuples and we've got to crack them open. How would you phrase it with the parameters?
Oh, okay. Yeah,
we don't have an integer sequence here.
I was missing that. Never mind.
Okay. In general, definitely a good question. Because if we could just mention the parameter names, then that's simpler. But here we actually do need this complicated full expression. Okay, I can already see that we got some stud qualified size t, which we should just not qualify at all because we're within stud. The two occurrences of stud size t here should simply be unqualified as we're within stud. So we'll always find the type def with no ADL concerns. Okay. The two occurrences of stud size t here should simply be unqualified as we're within stud, so we'll always find the type def, no ADL concerns. Okay. Wow, claim format, like it's really not having a good day here. Hopefully 15 handles this better. Okay, so we're going to have a const auto get smallest distance closure. That's a lambda that captures the tuples by ref. And it is templated, interesting, on a pack of stuff. Size t first idix. I don't know why this is commented out as default 0. We don't pass anything here. I'm really confused as to what's going on here. There's only two occurrences. We always just give it index sequence 4. We deduce. I don't see why we need this comment at all. It's not like it's been declared elsewhere to be defaulted to 0. If index sequence is empty, then I'm assuming we can't call this at all. This assumes that there's at least one. That's interesting. Does this have trouble if we are attempting to zip nothing? I'm not even sure if that's well formed, but that's the first question I have when I see something cracking open a pack of types and then assuming that there's always one. Okay, so I think that comment should be there. Then there's a question
zip
of what happens if this stuff is empty.
Forbidden by
it's forbidden.
Class
okay.
Requirements. Yeah.
Okay. Wonderful. Okay, but I think this comment should not be here. Let's see. Let's ask because I could be confused rather than saying there's definitely no reason for this, and then it turns out there's a reason, and I look silly. Let's see. What's the purpose of the comment equals 0? There appears to be only one use of get smallest distance closure. Immediately below, and it deduces first idix, so there's no default behavior. Okay, what's the purpose of the comment equals 0? There appears to be only one use of get smallest distance closure immediately below, and it deduces first idix, so there's no default behavior. Okay. Interesting, we are using tag dispatch because that's the only way here to get access to this list of types. If const expert has not quite superseded that. So we take an index sequence of first idix and then a bunch of idixes. Okay. I'm trying to look at what the first idix is used for. Where is it mentioned? It's not mentioned. Oh, it's just, I see what that equals 0 means. Here, it's acknowledging that the sequence will always start with 0 because we're using index sequence 4. So the comment is a reminder that first index will absorb the 0, and then the indexes are 1 and above. Here we just directly hard code 0 to get the first stuff, and then we look at the rest of them with the indexes. So it's not a default, it's a reminder of what it is. That's reasonable. It's just because I'm reading it strictly top down that I was confused. Okay, I'll retract my comment. I found the purpose. That's pretty thoughtful to have it, so thank you. Okay, so index sequence, first index, index dot dot. I suppose it could have just been named like 0, but that's fine. Okay, so what's going on here? We get a constant result type first size is static cast result type of stget 0 LHS minus stget 0 RHS. Okay, we're always doing left minus right. Okay. If that first size is 0, so if there are no differences between the first iterators, then the smallest is, you win, it's 0. We can just short circuit. Otherwise, maybe some of the other stuff is, otherwise we're non-zero. So maybe some of the other stuff is non-zero and we need to subtract. Now I'm assuming, this seems like it's assuming that none of these will be negative. How does the operator minus work? Is it doing some sort of absolute value? The value with the smallest absolute value. Okay. Okay, so if we find 0, that's by definition the smallest absolute value. So that definitely wins. But if we get non-zero, whether a little bit bigger than 0 or a little bit less than 0, maybe we'll find something at 0 later on. Okay. And there's no algorithm that really short circuits. Interesting that this is not, we're not taking the absolute value out of all of these. It's like doing the subtractions and then it's odd. I'm trying to think like what happens, because I haven't completely read through this. What happens if you have a mix of like negative and positive values, some are tiny, some are big, is what this is doing, which is not taking the abs immediately, equivalent to what the standard E says, which says the smallest absolute value. Because I would expect to directly translate the standard E's to apply abs, either call abs or do it manually, and then find the min. But this is doing something different. So this forms an initializer list, a named one, which is a little bit unusual. It's not wrong. It's kind of using it as a container, which is kind of weird, but not wrong. Then what are we, where are we giving sizes? Oh, it's being given to the ranges. Okay. That could have used an array, but initializer list is what the classic algorithm will take. So here we actually do want that. Okay, constant initializer list result type sizes is brace, whatever that first size is. And at this point, we know it's non-zero. And then a manifold expression, but a pack expansion of stdget indexes left minus stdget indexes right over and over and over. Okay, and then we do this odd sort of absolute value thing. If the first size was negative, then say we had like -10, then we look for the maximum of the sizes because we want to find the biggest. But this is assuming everybody's negative. I don't think that's right, because what if we have a mix of negative and positive? If we have -10, and then some of the other differences are like -11, -5, a billion, positive billion, then the range's max will find the positive billion and we'll return that. But really, we should have said the smallest absolute value, in this case, whatever I said, -5 absoluted, so should be like 5. Oh, I see. It returns the value with the smallest absolute value. So if the smallest absolute value, or if the value with the smallest absolute value is -5, we should return -5. We don't abs it, but we do want the smallest one. We should not return a billion. I think this is incorrect. if we have a mix of negatives and positives. I think it was trying to avoid greedily taking the absolute value because we do need to return the original one, but I don't think this is the right way to do it. In some sense, it's like the comparison should be done with absolute. We could give it a comparator that says, here's how to compare two values. You abs them, and then you compare. But then we can find the minimum according to that metric and then return whatever that is. That would be the right way to do it. So we'd only call min with a predicate. Okay, I think this is a bug unless I'm seriously confused about how this works. It sure seems like the minus should be able to handle iterators being at different positions. But I'm not really sure how all these, when zipping, are they always marching in lockstep? But then why would it talk about the smallest absolute value?
I'm confused. I don't think it's possible to get a mixture of negative and positive values, but that's because I don't think it's possible for the iterator pairs to ever get out of sync.
Right. Like, right? But yeah, I'm trying to figure out, why does the standard ease, why is it trying to handle like, what's the different absolute value? When I see that, my mind immediately goes to, okay, what if they're jumbled? But if it's like
I don't know why we're doing this min thing. I think all of the constituent distances should be identical, and we should be able to return any of them from this function.
Yeah, I mean that's how a zipper works, right? So that that's really weird. Is that just a defect in the standard?
Because of int. No,
so like if some of the difference types are like smaller than bigger, but then you would run out of space, like when the smallest one runs out of room for the difference type.
Nicole, can you explain to us stupid people?
Is Nicole on the call? She is not. So we are asking for telepathy. That's interesting. So I think this does merit a comment. The question is, should it be an LWG issue? What's going on here?
Sorry, I'm muted. Nicole has explained it in the chat.
oh, she's in the chat, just not on the call.
When our underlying ranges are common, the end iterator of the zip view is the end iterators of all the underlying views. And if we don't know the size of those underlying views, or they're not random access, so we can't grab an arbitrary iterator out of them, then we don't know that those end iterators are actually in sync with each other.
Oh, because you can exhaust some ranges.
We don't know how long the ranges are.
but what happens if you exhaust ranges before others?
You are at the end if you exhaust one of the ranges before the others. Yeah, the end of the zip view is when the first underlying range hits its end.
Okay, but in that case, aren't they still in sync? Don't they all still have the same value?
Yes, the iterator values of that iterator are in sync, but if you want to model common, so your zip view has an end iterator that it returns.
Okay.
But your underlying ranges are all forward ranges. They're all, say, they're forward common ranges. Then your zip view's end iterator is a tuple of the end iterators of all the underlying ranges. But they may have different lengths. So that is the only value out of sync is end.
Oh, weird.
It's the only way to get an out of sync value out of the design.
Okay. Because otherwise,
and that's why the equality comparison says if any of them compare equal, they're equal. Because that way the end iterator and the end and the iterator you reach by iterating through the sequence will be equal to the iterator that end returns, despite that they have different constituent values.
Okay, because you're considering it as soon as somebody has hit end. Okay, that makes sense. Yeah, so so going back here, this is doing subtraction, and it's trying to handle the case of what if one of these iterators is like the end iterator. You have to essentially, the position of it is virtually the one that's closest to the beginning, so the smallest absolute value. Is that right? It does get the right answer if you like subtract two end iterators, or if you strap n minus
Yes.
begin or n
So
minus
absolute value,
anywhere.
because the left-hand argument could be the end iterator value, or the right-hand argument could be the end iterator value.
Yeah, yeah. And you can't have anything beyond that point. So you don't need to worry, because if you try to increment, you do stop as soon as one of them hits end. Okay, so there's limited jumbledness permitted, but can't you still get into the case I had where you've got like a small negative and a big positive? Can't you have that?
No.
Oh, because they can't be relatively jumbled like that. It's either they're all in sync, or you are the end iterator and they're jagged.
Right.
But if you ever have a jagged case, that
You'll
means
never
that
advance
one's always
past the
beyond,
ends of one of
essentially.
those.
Yeah.
Negative number.
So regardless of whether one is before or afterwards, in the jagged case, they all have the same sign. It's never possible to have a mix of negatives and positives in the jagged case. And in the non-jagged case, it's also never possible to have a mix of negative and positives. Okay, so that's interesting. Okay, so that indicates this is correct, highly non-obvious. Okay, so let's read this with new eyes. Constant at list sizes is first size, and then get left minus get right over and over. There's no short circuiting if we find a 0, but we already tried to find like the case where, and the optimization is reasonable because most of the time, if they're non-jagged, then if the first one's 0, well, then hey, you're equal, you return 0. Otherwise, if they're not, the answer is very, very likely non-zero. It's only for like we're in a jagged case. We might find a 0, but we don't really need to optimize that. So I don't need to worry about short circuiting. Okay. So then return. If the first size is less than 0, it's negative. Then we assume they're all of the same sign. Try to find the maximum of the remaining sizes, because that one's going to be closest to 0. Otherwise, if the first size is not less than 0, but in this case we know it's strictly greater 0 because we already tested for quality, then find the minimum of all the sizes. Okay, that is correct. Agreed. And then at the end of get smallest distance, return get smallest distance closure, because we need to expand the pack, index sequence for LHS tuple types, brace, and we've already required that they be the same length. Okay, that is reasonable. Okay, and then an equal helper. Template on class.LHS tuple types. Class.RHS tuple types requires that the size of LHS is the size of RHS. Here I'm making sure that we don't mix up left and right. Very, very easy. It's no discard. Okay, so consistent with previous. Const per bool, zip iterator sentinel equal. Okay, so it's not iterator difference. This is, are you just equal to a sentinel? Const tuple LHS ref LHS tuple. Const tuple RHS ref RHS tuple. This one is strengthened. Not common to just strengthened, but this one is not exactly mapping to anything in the standard, so that's fine. We're no accept if this pack fold expression is no accept. Std-decaval const LHS ref equal std-decaval const RHS ref. Okay, comparing to const L values, they all gotta be no accept. Okay. Const auto evaluate equality closure is capture left and right tuples by ref. Okay, and then we're going to go invoke it. Template on size t dot indices, take index sequence of indices, and then just apply, is this equal to that equal, std-get indices LHS equals std-get indices RHS. And you're equal if any of them are equal, because you only need one to hit the end. Okay, so that's why it's or. Okay, so when we actually compute the answer, we fold over or, but when we compute no acceptness, all of them need to be no accept. So we use and there. Here we're anding the no accept, here we're oring the answers. Okay. Return evaluate quality closure on and index sequence for LHS tuple types dot brace for temporary tag. Yep, that's good. Okay. Now we can get to zip view. And here we have our first export stood because it is standard. Let's go out here. What's cool about export is that for the range of stuff, we actually need very few of them because so much of it is like helper iterators, helper sentinels, operator pren-prens. So we don't need a zillion of them. It's great. Turn off Clang format for Clang format 14. This is okay to keep. We'll clean that up later once we merge with Clang format 15. Okay, so this is exported because it's public. Template on input range ... view types requires view types and ... and the size of dot view types must be strictly greater than 0. Okay. We have a class zip view derived publicly because it's a class from view interface zip view types dot. Turn on Clang format. Okay, private data members, no unique address, comment it out. Someday it's going to be cool. We have a tuple of view types named views. Okay, that's that exposition only. So we got this here. Okay, and then template on bool is const, struct category base. And I believe that is the convention name. Template bool is const, we specialize requires. If they are all forward, assuming that's specified for, what are we doing? Iterator here. Let's see, this is an iterator. Do we have a specialization? This one says forward iterator tag. Trying to see if there's two separate standard eases. No, there's not. Okay. Let's talk about iterator category. Oh, I see. Okay. Yeah, this is implementing this here. But wait, is this wrong? Category base primary, and then template bool is const requires. When they're all forward, category base is const using iterator category input iterator tag. Iterator category is present if and only if all forward is modeled. Okay, what is the category? Is the category input? Okay, category is input, so this is correct, even though it doesn't seem like it is. Okay. So the category is conditionally input. Okay. My brain is like, if I see forward here, this should be forward, but no, the standard is more complicated than that. Okay, template on is const, class iterator derived publicly from category basis const. Okay, so that gets us type def. These are structs, so that's publicly available. That's good. Private data member, no unique address, tuple iterator t, maybe const view types current. That is this. In the zip view iterator, tuple iterator t, maybe const current. Okay. Friend zip view using extended friend syntax. Let's see, do we need that? Yes, we do. Because I'm a member as a child class, so I can access the parent class's contents because I have the same access as any other member. But if the parent wants to access the child class's contents, we need to declare friendship. Okay. Then we have context for explicit iterator constructor taking that tuple type undercurrent under. And that is going to be, is that even depicted? Not actually depicted. Oh, this is the private. Do we have an exposition only? No. It's just the standard just assumes that we can. Oh, I see this one. Where is this coming from? Where was that declared? Did I just scroll over it? Oh, it's hiding up here. Okay, so it is mentioned in the standards, just exposition only. Okay. Context for explicit iterator, tuple iterator t. How many times does this occur? Can we extract this with a type def? 3 times. Oh, no, 5. Oh, that's out there. Deco values. 3 is annoying enough that I do want to ask for extraction. Any more would be, my usual rule is if it's mentioned 3 times and if it's lengthy, then it's reasonable to extract. And it ramps here, which is really annoying. I'll suggest it. This. here we go. This thing is the one that occurs, yes. Occurs 3 times and is verbose enough to cause wrapping. Say suggestion. Extracting a, what do we want to call this? Current tuple, maybe?
My tuple?
My tuple. That would be the more classic name. But my tuple current kind of sounds weird. At least current tuple would reinforce the what we're talking about. It is my tuple because it is the only data we're storing. I'll offer both suggestions. My tuple type def or any other name. I won't be too picky about the name. Would help readability. Okay, suggestion, tuple of horribleness occurs 3 times and is verbose enough to cause wrapping. Extracting a current tuple or my tuple type def or any other name would help readability. Okay, otherwise this is fine. We're no except if, only one no except, 2 is a bug. If is no throw move constructible v of blah. Okay, because we do move it in, strengthened, current, move current. Okay, public. So iterator concept, see below. Here we go. Iterator concept is, if all random access is const view types, then a random access iterator tag. If they're all bidirectional, then bidirectional iterator tag. If they're all forward, then forward iterator tag. Otherwise, input iterator tag. Okay, good. Using value type. Oh, here's the value type. That is the type def. If only this were up a bit. Oh, no, it's different. Oh, it's range value t, not iterator t. Okay, so we can't use that type def. Using value type is tuple of range value t. Let's see, here we go. This here of maybe const is const view types, ... Okay. Using difference type is common type t of range difference t of maybe const is const view types. Okay. Default seed or default. Const expert iterator. Oops, I highlighted too much. Const expert iterator. Taking iterator of not const RHS, not I. This is strengthened here. And it requires. The strengthening is no throw convertible v from iterator t of view types. That's us. Convertible takes what we are, and then it's saying converting to. Is that the right order? That doesn't look right. Let me come back to that. What is the requirement here? So requires is const. I got to be const because I can construct a const iterator from non-const, and convertible to iterator t view types. Iterator t const views and ... So saying for all of the component iterators, the modifiable one, the iterator for the modifiable view, has to be convertible to the iterator for const view. You can always add constants, so that's fine. Because we're constructing an iterator, or we're constructing our iterator of const, because we're const, from an iterator of non-const. Yes. Okay, so then this is asking, this is mirroring it. It's saying, okay, I think this is right. Is no throw convertible v iterator t of view types? Not doing the maybe const thing. So this is actually the types within the RHS. Okay, and can we convert those to iterator t of? This is maybe const, not const. I think this is wrong. because we're converting to us, and we are is const, not as const. Like essentially, the strengthening here should substantially mirror the requirement for convertibility, except it's going to use
And they've
is
got
no
the
throw
requirement
convertible
wrong
v.
too.
Oh, is the requirement busted? Did I miss that? Oh, because
Yeah,
it's using maybe const. Oh,
but it's
I
using
missed
maybe
that.
const, and yeah, the
Yeah, it needs to be
standard
const
doesn't use
views.
maybe const here.
Yeah, good point. Okay, so yeah, you're right. Requires is busted. And then I'm virtually certain the strengthening is not right. They should mirror, essentially. It should be is no throw convertible v iterator t views to iterator t const views, because it's not just enough that it can be convertible. Like this describes the conversion we're going to do. Then we need to ask, can you do that without throwing? So it needs to use the type trait rather than the concept, but otherwise it should be identical. Okay, yeah, I think
Agreed.
that's a bug. I'll comment on that. Okay, thanks. It's always nice to know that I'm not just jumping in phantoms. Okay, current std move RHS current, which will do a component-wise move of all the stuff in the tuple. So at least that's easy. I'd really love to have no except auto. I'd love to have requires. Like if I'm just well formed, I know why the standard at least doesn't have just the requires if the body's well formed. I'd really love that no except auto though. Having a look, the specification for the constructor is like 10 times the size of the actual implementation. The compiler knows whether the stuff is going to throw. We're definitely working around a limitation of the language here. Okay, let's comment here. Should I have 2 comments or 1 comment? Cameron's joking that that'll be his next hackathon project. I think probably 2 comments because they are different. Let's comment on the requires first. Here I will give credit. Casey noticed that the standardies says, let's not highlight here. Let's get everything here. But which doesn't use maybe const. Actually, no, let me say, so the usage of maybe const here appears to be incorrect. Okay. Casey noticed that the standard says convertible to iterator t views, iterator t const views, and ... So the usage of maybe const here appears to be incorrect because that's the one missing thing. Okay, got it. And then a comment about this here. So we think the iterator t view types is right, but this one should really be const. And in fact, even ignoring that, like this is maybe const is const, this one says maybe const not as const. So that's just opposite. I noticed that this, should I comment on the whole thing? No, it'd be distracting to get the signature in there. That this exception specification says, let's see, should I just extract? Now I'll extract the whole iterator type. How many ingles is that to? Let's see, we are, because should I mention there's 2 issues here, but one that flips the constness, or I want to say flips, that has the opposite constness of what we're actually converting here.
I'm standing in a house.
Let's see. I'll explain because this is confusing. This constructor is using this constructor takes a non-const iterator as the source to construct a const iterator destination. So the is no throw convertible v type trait is given the should be given. I want to avoid any confusion about like what it should be given versus what we actually wrote in the source code. Should be given the non-const source iterator first, which it is. Iterator T view types. And then it should be given the const iterator destination second. Okay, I think I have explained that. Okay, and this is big enough that I really want bullet points. 1, then 2. Let's see. This should match the requires clause, which says, select again. Let's grab the whole thing. Let me explain. Except changing, or except using is no throw convertible B instead of convertible 2 says iterator T const views for the second argument. Okay. I noticed that this exception specification says iterator T may be const not as const view types, but that has the opposite constants of what we're actually converting here. This constructor takes a non-const iterator as the source to construct a well, hold on, I'm getting confused. Let me restart. I noticed that this exception specification says iterator T may be const not as const view type, but that has the opposite constants of what we're actually converting here. This constructor takes a non-const iterator, correct, as the source to construct a const iterator destination. So the is no throw convertible V type trait should be given the non-const source iterator first, because we go from to 2, which it is, iterator T view types, and then it should be given the const iterator destination second. I'll bold that because that's the important bit. Okay. 2, this should match the requires clause, except using is no throw convertible V instead of convertible 2, which says iterator T const views for the second argument. I'll credit you again, similar to what Casey noticed. There. Okay. That one tiny little character, not expanded into a big comment, but I think we got this sorted out. This sort of thing is just, it's possible to test, but it's really obnoxious to test. You got to write a lot of test support code to validate this tiny thing. So I wouldn't ask for test coverage here. It's totally understandable how it's missed. I'm satisfied if the code expresses the conversion that we're actually going to do. I don't think we need test coverage of this. Okay.
The comment in the middle of the screen right now.
Yeah.
It appears to be incorrect. Appears to be incorrect isn't really quite true. It's correct because we've constrained is const to be true already by the time we get here.
Oh, that's right. Yeah.
It's just a little overcomplicated.
Okay, good point. Yeah, because we are, requires is const. Okay, good point. Okay. We've constrained, the constraint has already guaranteed that is const is true. So using maybe const is const is correct, but unnecessarily verbose.
Yeah, that'll work. And now I'm wondering if maybe some of this is overly complicated to avoid Clang bugs
Oh,
with premature substitution.
well, yeah, then it should be marked as transition.
Yeah, true.
Yeah.
We'll find out.
The constraint has. Yeah.
I'm not worried about it.
Okay, the constraint has already guaranteed that is const is true, so using maybe const is correct, but unnecessary verbose. Okay, thank you for that correction. Let's see, I think we can get through, can we get through the rest of this iterator? This iterator's big. Let's see how much we can get through in the next 5 minutes. Okay, so we got a deref. Wow, iterators can dereference. Const expr auto. Okay, so now we're going to pay attention to whether things should be no discard after the constructor. Dereferencing should absolutely be no discard. Const expr auto operator star const. This is going to be strengthened. Okay, so we've got a non-trivial strengthening here. We're no except if this fold expression is all true. We need to be able to dereference a stud decal of iterator t, maybe const is const view type. So potentially apply constness to each of our component iterators. They all have to be no except because we return a tuple references. So at that point, we're fine. This looks correct. The parenthesis here is not necessary because it's unary and there's no other way it could bind. I won't comment on it. It's not wrong. And again, this is a pretty complicated expression, pretty complicated code. If this were a smaller PR and this were like the only issue I found, I would probably comment on it. But this is fine. Trying to be a little bit more easygoing in my reviews. Okay. And then this is going to return tuple transform. Ooh, interesting. We have a stateless lambda that takes an auto-ref iter because the tuple transform works on every component of the tuple. Is that right? Trying to remember. It was like an hour ago that we reviewed this. Zip get smallest distance. No. Tuple transform. Apply to every element that will invoke something. That's high-powered machinery for what's just a lambda invocation, but that's fine because it's the one that we use for users as well on every element of the tuple. Okay, so we use it down here. Here, tuple transform lambda, take auto ref under iter, and we're going to return decal type auto. This is necessary so don't get any sort of decay. Return deref iter on the current tuple. Okay, and then that will return. Tuple transform should return a tuple of references. Let's make sure that's right because we're not directly naming the type here. I think it is because of decal type auto and we used invoke result t. Tuple transform returns whatever std apply does. Interesting. And then the tuple transform closure returns, here we go, a tuple of invoke result t. So if the lambda that we give it returns a reference, which it does because it returns decal type auto of dereferencing, and ideally that should return a reference, then we're going to get a tuple of references. That seems right. And if it happens to return a PR value, which you could get for an input iterator, that'll participate in the tuple as well. And I'm assuming, without looking, that that is what this does. Yes, this is directly translating the standards. Okay, I'm convinced that's right. So that is this, effects equivalent to, wonderful. And, okay, incrementing. Not no discard, because we can definitely discard this. Const expr iterator ref op ++, and then this is strengthened. We're no except if this is no except. Can we call tuple for each with essentially what we're doing in the body here? Okay. It's too bad we can't centralize that lambda. Effects equivalent to tuple for each. Ref auto ref iter, increment iter on current, return deref this. Okay, looks good. Const expr void operator ++ int. This one also strengthens. No except if no except. Pre-increment, again, a redundant parenthesis, but it's consistent, which is good. Std decal iterator. It's us. Why can't we just say deref this here? We have access to deref this in no except, don't we? We had problems like, I'm asking because we had problems like 12 years ago when no except originally occurred. I'm virtually certain it's okay now. Where did that occur? So like no except here for this. Or no, not do that. Let's do a regex search. No except dot star back star. This. Okay, concepts can do that. Yeah, when we're comparing two arrays. Yeah, we can totally mention derif this. I think we should do that. Because it is the body. I believe we should be able to say no except of no except of plus plus derif this and paren here. Okay, looks right. Just do that. Return void. And then post increment. This can be the last one we look at. Oh, sorry, not post increment. Oh, it's the other post increment. The one that is constrained for all forward. Okay. Where is that? This one here. So context for iterator, again, discardable. Plus plus int. It's going to have requires, but first we have a constraint. This actually occurs repeatedly. I'll update this. Occurs below also for decrement. Okay. So this one here requires no except if we can pre-increment, sure. And because we return by value, is no throw copy constructible v iterator is const. Oh, that's our const. Why does it say iterator is const, not iterator? Using the injected class name. That's us. That should just be iterator, according to our conventions. We have access to the injected class name even in no accepts. There should be no reason we can't use that. How often did this occur? Very rarely. Okay. That's the first occurrence. Again in postdec, and this is separate because this is in zip view itself. So we do need to mention is const there. Oh, this is like Sentinel. Yeah, Sentinel is const, needs to form. Iterator is const. So yeah, these two are the ones that should just use the injected class name. Let's see. We should be able to use the, let's be fancy, italics, injected class name under iterator here instead of saying there is const. Occurs below in the decrement one. Okay, we should be able to use the injected class name iterator here instead of saying iterator is const, occurs below an operator minus int. Yeah. Okay, that's strengthening, and then requires clause. All forward is const view types dot. We make a const auto temp that does not appear in the standard, is drf this, increment drf this, return temp. Let's see, does that const interfere with the return value optimization and the move semantics stuff? I think I've actually lost track of whether it's important. I think we should do what the standard says and not mark it const. That's one of our exceptions to apply const to everything by default. Is that right, Casey? That this local variable should not be for this post increment where we should say, where the standard says, say auto temp is this, increment this, return temp. Marking that as const, that inhibits the automatic moving and maybe the named return value optimization. I think it doesn't inhibit NRVO.
Yeah, I don't think it should inhibit NRVO, but yeah, definitely automatic move is going to be inhibited if NRVO is not usable for some reason.
Yeah, so I think we should omit the const here, despite our love of const everywhere.
Yeah, I would rather that we didn't const things that we're going to return. Yeah.
Okay.
For that reason.
Okay. Although const is one of our favorite keywords, and we mark local variables with it whenever possible, this is a rare exception. When returning a local variable, this can inhibit automatic moving if the named return value optimization doesn't activate for whatever reason. The standard ease depicts auto temp, and we should use skipping words, we should use non-const auto here match it. Occurs below. Okay. Although const is one of our favorite keywords and we mark local variables with it whenever possible, this is a rare exception. When returning a local variable, this can inhibit automatic moving if the named return value optimization doesn't activate for whatever reason. The standard ease depicts auto temp, and we should use non-const auto here to match it. Occurs below. Okay. And we are now at time limits. So I will, I think, submit a partial review. Looks like we actually got halfway through this header, even though it feels like we've haven't got that far. There's a lot of the logic in the iterator. The actual view itself is pretty small in comparison to its iterators, because the iterators are where all the fun stuff happens. We've already seen how it forms the dereference of everything and compares two iterators by using equal or subtraction. So this is pretty cool. I will submit a partial review and then come back to this later after the toolset update and finish reviewing so we can get this ideally into 17.5 preview 2, although depending on logistics, it may or may not get into that release. We're going to try though. Okay, I'll submit this offline. As always, thanks for watching this, and we'll see you next time on the Open Code Reviews.